Okay, let's unpack this. Today, we're diving into a really interesting generational clash in the RC world. We're pitting the modern Tamiya Superstock BZ against, well, a true legend, the vintage Acto-Power Off-Road 2WD.
Yeah, and this isn't just bench racing stats. We're looking at how they actually perform in the same test bed.
Exactly. And that test bed is a Tamiya Frog. But hang on, not the stock one.
No, definitely not. This Frog is seriously fortified Think Restomod. It's got the MIP Super Ball diff, carbon gearbox plates, CVDs, the works.
Right, the essentials to stop that notoriously fragile stock gearbox from just, instantly grenading.
Absolutely. So the chassis weakness is basically eliminated. It becomes all about the motor and the power system.
Which brings us to the mission. For you, the listener, we want to see how these two fundamentally different motors behave under one very specific, very critical constraint.
And that constraint is the power source.
Yeah.
A standard 5,000 milliamp hour, 7.2 volt NIM-Edge battery pack feeding a Hobbywing 1060 ESC, a very common, very popular setup.
Okay, let's get into the specs. The BZ, the modern one.
Right, the Superstock BZ item 5393. It's a 23-turn motor, a modern design philosophy, focus on torque, efficiency. It puts out about 26,500 RPM, but the key number is the torque, 49 millinewton meters. That's some serious grunt for pulling out of corners.
And it's built for reliability too, right? Vented can, heat sinks.
Exactly. Terminal heatsink, dust cover. Designed to manage heat and just keep running.
Now contrast that with the Acto-Power, the pink can.
Ah, yes. Item 53122 from back in 92. A totally different beast. It's a 14-turn double-win motor. Pure competition focus back then.
14 turns, so way lower turns, aiming for max RPM, max speed.
Precisely.
Yeah.
But the trade-off, it's got a sealed can, no vents, so thermal management becomes, well, let's just say it's a challenge.
23 turns versus 14, efficiency versus raw power draw.
Okay, and here's where it gets really interesting, especially with that Hobbywing 1060 ESC.
What's the deal there?
Well, Hobbywing rates the 1060 for brush motors down to 12 turns.
Okay.
The BZ at 23 turns is way, way within spec. No problem at all.
But the Acto-Power, 14 turns, that's really close to the limit. Shouldn't that, stress the ESC, maybe even fry it?
Under normal circumstances, with a modern battery, absolutely you'd be asking for trouble. Constant high current draw, potential meltdown.
So why doesn't it? What's saving it here?
It's the NIM-H battery. It's the unsung hero. Unlike a LiPo that just dumps current, a NIM-H pack has characteristics.
Like what?
Voltage sag. Under heavy load, the voltage of the NIM-H battery drops noticeably.
Okay.
And that voltage sag directly limits the amount of current the motor can actually pull. It acts like a natural governor on the system.
Ah, I see. So the battery itself is preventing the 14-turn motor from demanding too much continuous current from the 1060 ESC.
Exactly. It throttles the power draw just enough to keep the ESC within its operational comfort zone. That's fascinating chemistry in action.
That makes perfect sense. The old tech saves the system from the other old tech. So specs and chemistry aside, how do they actually drive? What's the feeling on the dirt?
Right, the BZ setup first. With the NIM-H, it's absolutely the marathon runner.
Meaning?
That big torque figure. The NIM-H smooths out the initial punch. You get strong, very linear, very predictable acceleration. Super easy to control coming out of corners. And because it's efficient, and the NIM-H limits the peak current, it runs incredibly cool. You get really long run times. Consistent performance lap after lap.
Okay, the reliable, consistent workhorse. Now, what about the Acto-Power, the tamed beast, as you called it?
Yeah, the NIM-H totally transforms it. That raw, high RPM nature is still there. Absolutely. You can feel it has a higher top speed. Definitely pulls harder on the long straights.
But it's not uncontrollable, because a 14-turn can be twitchy.
Not with the NIM-H. The power delivery is smoothed out. Doesn't have that insane instant kick that could overwhelm the chassis or the driver. It still sounds more aggressive, feels faster, gives you that vintage racing thrill, but it's surprisingly manageable. Forgiving, even. The Restomod Frog handles it beautifully.
So the NIM-H really does level the playing field, making the vintage motor viable without immediate risk.
Precisely. It mitigates that inherent thermal risk of the low-turn sealed can motor.
So what does this all mean? If someone's building up a Frog like this, which motor should they choose?
Well, it really depends on what you prioritize. If you want maximum runtime, total consistency, predictable power, and just hassle-free performance, you go for the Superstock BZ. It's potent, but incredibly reliable in this setup.
Okay, the sensible choice for long bash sessions or clean racing.
Right. But if you're an enthusiast, if you crave that absolute maximum top speed, that nostalgic high RPM scream, and that period-correct authenticity,
And the Acto-Power.
then the Acto-Power, yeah.
Okay.
The NIMH battery makes this vintage legend surprisingly practical and honestly a really fun, exhilarating drive without being terrifying.
It delivers the speed rush, but tamed just enough by the battery.
Exactly. But this whole comparison really highlights something critical, a final thought for you to chew on.
Okay.
The NIMH battery saved the system here, right?
Right.
It prevented the Acto-Power and the 1060 ESC from overheating due to excessive current draw. So, what do you think happens if you take that same Acto-Power motor, that same 1060 ESC, and you swap out the forgiving NIMH pack for a modern high-discharge 2S LiPo battery?
Oh, uh-oh. No more voltage sag governor.
None. You get instant, massive current delivery. The answer is immediate, potentially catastrophic stress on both the vintage motor and the ESC, pushing them way beyond their design limits.
Wow. So the battery isn't just power capacity. It's maybe the most crucial tuning variable in the whole system, especially when mixing old and new tech.
Absolutely. Battery chemistry, it dictates performance, safety, and compatibility, something crucial to consider in any build.